It freezes. It's frozen. Huh? Um, let's stop it under and or no.
No, if I stop it.
Oh yes, you lose. Oh, he start another one. Okay.
Yeah, I don't know what happened. I tried to share my screen, and the whole thing locked up. Let me try again.
Okay.
Okay. Do you see the screen?
Yes.
Okay. So I'm going to start. What I'm going to be talking about is a project that I've been working on for the last couple of weeks that's now published. It's called S2M, and essentially it allows you to connect Scratch to the microbit microcontroller board. And I'll explain, if you're not familiar with microbit, I'll be talking a little bit about that. I'm assuming everybody knows what Scratch is. Hold on. Okay. Let's start. So just a little bit about me, where I'm located.
Alan, yeah. you have two of you online.
I have what?
Okay. Yes, that's okay now. And just to say that Hajime Araki-san from Tokyo is with us. I think everybody knows him already.
Sorry, too late.
Okay, hello, Hajime.
Hi.
We are just starting it now. Just now.
That's great.
You are welcome.
Okay.
Okay, let's go for it.
Go ahead.
Okay, so I'm located in New Jersey here in the United States. I'm pretty much in between New York City and Philadelphia. I grew up in New York City as a kid in Brooklyn. So for contact information, if you want to contact me, my email address is at the bottom of all the slides. And here's the email address. All of the projects that I've worked on that I've published are on GitHub. So all the source code is available. And I also have that link at the bottom of every slide, so you don't have to rush if you want to copy it. I have a blog that I use on occasion. I'm not very active on it, but I do send, I do publish some articles. Twitter, again, I'm probably on that even less, but I do publish some things on Twitter. I have published in the past some Instructables articles. I haven't done anything in a long time, but they're still there as well. And those are mostly on Arduino. A little bit about my background, my professional background. I have a degree in software engineering and worked as what's known as an embedded software engineer. Embedded just means I'm close to the hardware. Did that for close to 40 years, and I'm now retired. Worked for companies like AT&T, Lucent Technologies. I was at Bell Labs during that time. I've also taught. I'm not formally trained as a teacher, but while I was working doing software engineering, I worked part-time as a university instructor, undergraduate in Java and C++. I also worked as a corporate trainer, also teaching people in Java and C++, and that I did for AT&T. When I stopped working as a software engineer, my local middle school had hired me as a special education teaching assistant, kids that have special needs, that had learning problems. So it was a one-on-one. I had 3 students in the couple of years that I did that, and that I really enjoyed, but they no longer needed my assistance. They had a bunch of kids with special needs that were coming through the system, and those kids just went on to high school, and they didn't have need for my services in that. So unfortunately, I had to stop that. While I was doing that, I also started an after-school Scratch programming club, and that was really a lot of fun. Working with the kids who were 10 to 13, and I really enjoyed that, and they seemed to like it as well. Another thing that I'm doing, and this I'm currently doing, I'm what's called a literacy volunteer. It's an organization. I think it's international. It's definitely within the United States. It's for adults. It's to teach people English for folks that have not learned English as their first language. ESL means English as a second language. So it's people who have come to this country, immigrated to this country, and want to improve or learn English. And also there's something called basic adult education. It's for people who were born here, but for whatever reason, never learned to read or are having problems reading and writing. I've worked with both. They've been, I started off working with some folks from Egypt, and had a lot of fun. One of the students I had went on to, was admitted to college, and that was pretty rewarding. I'm currently working with an adult, a basic adult education student, and we've been together, I don't know, about 3 years. And he went from pretty much being totally illiterate, and now he's reading Stephen King novels. So it's really very rewarding. And I'm still doing a lot of software development, which is really what this talk is about. And all of that is available on GitHub. By the way, you can stop me at any time if you have any questions about anything. So we're going to talk a little bit about the microbit, just to give you an idea. If you're not familiar with it, it's a tiny little computer. You can see from the picture how small it really is, but it's really packed with a lot of things. It's very inexpensive compared to some of the other things. Just to give you a comparison in price, an Arduino board, which does not have anything other than to use an Arduino, you have to buy a whole bunch of additional things to make it useful. The board itself is, in US dollars, is about $25. If you buy the official board, you can get them for as low as about 10 if you buy a clone. A Raspberry Pi here is about $30. This board is, although you can get it sometimes for $10, it's usually around $15. The advantage of it is that it's packed with a whole bunch of things. You don't have to start wiring things up. So what it has on it, you can see here, there are these little holes, and they're labeled. So there are 3 input-output ports. If you wanted to connect other devices, you can do so. And unlike the Arduino and the Raspberry Pi, these are fairly large holes, which means you can use an alligator clip to hook things up. It's a lot easier for small hands and for older eyes as well. But you don't really need to get involved with these pins at all. It has over here, these are individual LEDs. It's got a 5x5 matrix of LEDs that allows you to put up different images, and we'll see that in a little bit in the demo. It also allows you to scroll text across here, or you can turn on and off each individual LED. You can set its brightness as well. It has 2 push buttons that you can use. It comes with an accelerometer and a compass. The accelerometer is really used, and again, I'll demonstrate this in a moment. If you tilt the board either forwards or backwards or left and right, you can detect that. It also has something, and this is something I have not played with yet. It has Bluetooth built in, and it also has a function using Bluetooth. It's not the normal Bluetooth interface, but they call it radio. And what that allows you to do is you can actually connect 2 or more. Actually, I think it's up to 256. I'm not really sure the total number yet, but multiple microbits together using a radio signal, and that's exposed in their programming languages. One of the really nice things I think about it is that you can program. Now, for the program I'm going to show you, you don't have to do any programming. I provide the program for you. But if you wanted to program this directly, you can do it in Python. You can do it in JavaScript, and they have editors for Python and JavaScript. The JavaScript, you have a choice of doing it in text or with a block editor. There's a limitation in Python that they currently don't have any Bluetooth support. They have radio, but no Bluetooth. The reason for that is that there's not enough memory on the board. And what they had said was that supposedly there's a newer version eventually that's going to come out that'll have more memory. At that point they'll support it. The other thing that you can program in is C++, and C++, allows you to do a lot of very low-level things with it if that's something you want to do. But it's a little more complicated in terms of setting up the programming environment. With Python, there's you just download an editor, and the same thing for JavaScript. And that's pretty much what the microbit is. So what is this thing called S2M? So it's a program that essentially allows you to take Scratch 2.0 offline and connect it to the microbit. There will be blocks, and you'll see this in a second. It's written in pure Python. It allows you can use either Python 2 or 3. If you're not familiar with Python, it has a strangeness about it in that there are two versions. They're not totally compatible with each other, which is a little strange. So if you get some Python 2 program that was written for Python 2, it may work on Python 3 and vice versa. What I did was, you can write programs that are compatible with both, and I did that because it's unclear what somebody has. So if they already have one version loaded on, they don't have to get involved with loading the other version on their computer. And again, what it allows you to do is, through some custom Scratch blocks, it allows you to program the microbit. And we'll see that in just a little bit. So the features that the program supports is that it allows you to put various shapes on that LED display. You can also control the individual LEDs, scroll text on the display. It supports those 3 digital and analog I/O pins, so that if you connect something like a motor, you can do that. It can determine what I call a tilt state. So you can tilt the board, and it'll tell you, is it tilted down, up, left, or right. It also detects if the board has been shaken, and it allows you to detect the state of those 2 push buttons. To run it, here's what you would need if you wanted to try it out. You need some sort of computer, a Windows-based, a Mac, Linux, and I've also, this also runs on the Raspberry Pi. So if you're using Raspberry Pis, the latest version of the Raspberry Pi operating system has a version of Scratch. It's kind of strange. It's offline, but it's based on the Scratch X version of Scratch. But this program, S2M, will run on the Raspberry Pi as well. You obviously need a microbit. You need to download the Mu editor, is that editor to edit Python and load a Python script onto the microbit. I provide the script as part of the distribution. So you just need the editor, which allows you to load it, the program onto the microbit. You would need either Python 2 or 3 installed on your computer. You'll need the Scratch 2.0 offline editor installed. If you have a Linux system, you may not have very good luck installing it. The Scratch people have not supported Linux very well. And the latest version of the editor, I can't get that to run on Linux. And it has to be 32-bit Linux. It won't run on 64. So anything, but it does run on the Raspberry Pi, because the Raspberry Pi folks adapted it for their own operating system. So once you have all of this stuff available and installed, all you do is open up a command window, type S2M. We'll see that in a second. And what that will do is it'll start the program and automatically open Scratch and have the blocks installed. There's also a user's guide that I have. Here's the link. If you go to the main page for the distribution, there's a link for it there too. Okay, so let me switch over to, I'm going to demo this if I can find it. Okay, I'm running Windows in what's known as VirtualBox. I don't know if you folks are aware of VirtualBox. I actually run Linux normally, and there's this thing called VirtualBox, which will allow you to run another operating system within your computer. So if you have a Windows computer or a Mac computer and want to try Linux or one of the others, it allows you to do that, and that's what I'm doing here. So this is, okay, there we go. Oops. I'm going to open up a command window. And all I'm going to do here is I'm going to type, oops, S2M. What you're going to see is Scratch is going to open, hopefully. Program is starting, and I'll explain what is on the screen in a second. I'll let Scratch open.
We are seeing Scratch open. I don't know, I mean, if it is the thing that you want to show us.
Yeah, you see Scratch?
Exactly, yes. But
yeah.
It seems like prison.
Yep.
Frozen.
So what I did was I started S2M, and what it happens is it first looks for the microbit. It announces itself. So here, I started S2M just by typing it in. Tells me the version of S2M I'm using. It also, and this is mainly for me when people have problems, it looks and sees what version of Python is running. It then goes to see if it can find the microbit. And in this case, it found that it's on COM4. It also tells me the version of the script that's running on the microbit itself. And again, this is more if somebody's having problems and they contact me, that I can help figure out what may be going on. It'll auto launch Scratch, and I'll explain this thing about the HTTP server a little bit later. When you want to exit, you hit Control-C in this window, and it'll kill the Scratch window as well. So if you go into the More blocks, what you'll see is these, let me expand this so you can see it. These are all the custom blocks to support the microbit. So you can display different shapes on the screen: happy, sad face, smile, confused, all these different things. There's a whole bunch of them that are here. Arrows. You can scroll text by just typing something in here, and it'll scroll across the screen. I'll give you a demo of the display once I'm done with the rest of the demo, because you can't put the camera on at the same time as sharing the screen. You can clear the display out, control the digital and analog pins by setting their values. And you can also monitor the buttons, A and B, determine if the user has tilted the board up and down, whether they've shaken it. And you can also read those I/O pins. So what I'm going to do is I'm going to load a project I put together a little while ago. So you can actually see this work. Okay, and let me expand this.
Alan? Alan?
Yeah.
I can see only a screen.
Yes, you're only able to see a Scratch right now, right?
Only a screen? Or another screen you were showing?
No, I'm in Scratch.
Yes, did you change something? Because we are seeing the same picture and nothing happening. It's a Scratch offline editor with the more blocks showing. That's all.
Right, you're seeing that. So
yes.
So
did you did something new?
Yeah, I just started. I'm gonna explain what's on the screen and demo the program for you.
Okay, because we are feeling that nothing is changing on our screen.
So
on the screen.
let me do something, and you can tell me if you see something changing. Did you see?
Okay.
You see this?
The screen is frozen. It's not.
Yes, this is the point. Yes,
okay,
we are.
Let me go back in and let me reshare the screen.
Okay.
Okay. Hello, everyone. Good morning. Sawan King. Hi.
Is that better?
Oh, yeah. Okay. Now it's changed.
Yes.
Thank you.
Okay, I'm sorry.
Yes. Now it's moving. I mean.
Yes.
Okay.
Thank you.
So what I have, this is a little demo, and what I did was I put two sprites up. I have the cat and a ballerina, and what will happen here is once we're done with this, I'll show you what's going on with this part. In the cat, I'm going to, on that LED display, I'm going to alternate showing a square and a smaller square, but we'll see that in a little bit. If I shake the board in my hand, what will happen is he's going to move 10 steps, and if I press button A, it'll say, hello, ballerina. If I go to the ballerina, if I tilt the board, different things happen. If I tilt it right, the color effect will be changed by 25. If I tilt left, the color effect is turned off. If I tilt up, the size will go back to 100%, down, which is what it's now, 50%, and shaken, she moves a little bit slower. And also, she also listens to the button press. So let me start it so you can see what's going on. So you can see that.
Change the colors.
Yeah, so I right now, if I tilt to the right, which is what it is, the color is changing. If I now tilt to the left, unfortunately, you can't see this because I can't have the camera on.
Yes.
Actually,
no, I mean, we got the algorithm. I mean, you are stopping now tilting, right?
Yeah.
Yes.
So now if I tilt up, she's full size. I tilt down, she is part, of half the size. If I press button B, she says, hello, cat. Press button A, which is in the cat's side, he says, hello, ballerina. And now if I shake the board, and I'm shaking it up and down, they're both moving. So what this is doing is it's allowing me to interact with the sprites in Scratch and the microbit. So I'm using the microbit to change features of like the color features here. I can get them to move by playing with the board. Those are the kinds of things you can do. What I'm going to do is I'm going to go back to the camera so that you can actually see what the
Oh, yes, please.
What this part is doing, where I'm actually playing with the display. So let me go back to oops. Try to figure out how I'm going to not share. Go back here. Okay, stop sharing. Am I back on screen?
Yeah.
Okay, so let me hold up the microbit so you can see it. And I'm changing the display, and this is being done in Scratch is running now. So I can put any shapes I want in there. I can scroll text on the screen. And it's allowing you to, again, doing some physical computing fairly easily. The kids don't have to worry about programming languages. They can just interact with the hardware. Okay, let me continue with the presentation. Any questions about this? Okay. Okay. Are the slides back up?
Yes.
Okay. One of the things I have, there is a Japanese translation that's available right now, and you can, if you start it up, instead of just typing S2M, you give an option and it'll install the Japanese blocks. What I've tried to do is I've given instructions. If anybody else wants to translate to any other language, there's instructions in the manual. I'd be happy to help out. And, if you want, I can certainly include that as part of the distribution. it makes things a little easier for the kids if it's in their own language. Just to give you an idea, and I'm not going to spend a lot of time on this. This is the architecture of how this thing works. Essentially, on one side, you have Scratch. The other side, you have the microbit. Scratch has something called an extension specification. What they did was to allow you to create your own blocks. They wrote something that you write a file, and they describe how to write it, that allows you to create the blocks. When the blocks execute in Scratch, for this particular interface, they send out HTTP messages, similar to what happens with your browser. And actually, S2M, the program, everything in this block is S2M. There's a little HTTP server. So it can receive those messages. The messages say what block is being executed, if there's any data, what data is associated with it. So like the display, it's telling when it says make it the large square, it tells S2M that's what it wants. The problem is microbit has no idea about the HTTP protocol. I wrote something on this end, that's the program you load on the microbit. It has its own protocol using the USB cable, the serial interface. So microbit knows nothing about HTTP, Scratch knows nothing about the microbit, and essentially all that S2M does is it just translates the protocols in both directions so that these two things can talk to each other. And that's really all it is. Why I did this was I had actually no intention of doing any more Scratch interfaces. They're not all that pleasant to write. But somebody had contacted me and said they really wanted it. So I figured, okay, I did not own a microbit, did not know a lot about it. But since it was so cheap, I figured, let me take a look. It looked interesting. And what I found out was I thought there would already have been a Scratch interface. There is one from ScratchX that comes from somebody that works, he's a member of the Scratch team. But he wrote it in a way, one, it's only online, which is nothing wrong with that, but his version only works with the Mac computer, which is kind of limiting. One of the things that I learned from my other Scratch interfaces is that a lot of folks prefer the offline, and that's because there's poor internet connection sometimes, and sometimes none at all. So I had done some ScratchX things, which uses the online version, and people complained and said they want everything offline. So that's one of the reasons that we did this.
Sorry, I
Yeah.
have a question.
Yeah.
About the HTTP server, do you need to install HTTP server with the Scratch, like I don't know,
No, it's built into S2M. So when you start S2M, it starts the server automatically. So
you added this feature. I mean, the web server, you added it on Scratch, right?
Well, it's not on Scratch. It's so if I go.
Sorry, on. Okay. Yeah.
Yeah. So Scratch talks in HTTP for this interface. The program that I wrote has an HTTP server built in. Within Scratch, when you build the extension blocks, in the file that you do that describes what these blocks look like, you tell, and everything runs on the TCP IP address of localhost, if you're familiar with that is. So it's just running on the local computer. And in that, the extension itself, I picked a port to use. So Scratch knows what port to talk to, and it matches the port that I have in this HTTP server that I'm running. So you don't have to start anything other than S2M. All of this stuff starts up for you automatically. Did I answer the question?
Yes, yes. I will come back later. I might ask you another question, because for the HTTP server, for example, for Scratch, as I know, there is only the Snap version. There is the Snap for Arduino. It runs like there is an embedded HTTP server, but for the Scratch. Sorry?
Yeah, this is embedded also. It's written in Python. It's about 3 lines of Python code.
This is amazing because I love HTTP requests and for Internet of Things, I mean, communication. So I'm really interested about that.
Okay, fine. Yeah, again, that's all there. The way that I've been trying to write things is to make things easy, both if you're using it in the classroom, it's just to make it easy for the kids to start, for the instructors, so they don't have to know all of these crazy details. I'm just giving this so that people have a little bit of background. You don't have to know anything about any of this. Okay. So I had said that I really wasn't all that interested in writing this initially. And it's because the Scratch folks really have not been very, very good about supporting these extensions. And while writing this, I encountered yet a new bug in their specification. When we scrolled text across the screen, certain characters, instead of being printed, you would see a % and the hexadecimal equivalent of that character. So to give you an example of what I'm talking about, if you put a space like hi Bob, what you would see the HI, but no space. What you would see a % character and the numbers 2 and 0. It only happened for some characters, didn't happen for others. So and you can see that here. This is what it looked like coming across the screen. I fixed that. That's on my end. I have a workaround. But you can't even report the bugs. They don't do anything about it. There's nobody to report it to. They just don't support this at all, which is really very sad. And it's the same thing, by the way, for ScratchX. That's even worse because of the way that they run that. Also, the latest JavaScript ScratchX things is a better interface than this HTTP stuff. There's nothing wrong with HTTP, but the way the Scratch interface works, when you're trying to do the reporting of data, things like reading whether the board is tilted or not, it's not asking, when those blocks are executing, it's not saying, can you tell me the state of the button or the tilt of the board? 20 times per second, they send a general command that is what they call a poll command, and you got to send them all that information. What that causes, it causes all sorts of synchronization headaches. It's just not a very well-designed interface. And some of us complained about that in the beginning, but again, they didn't really care. They just left it. It works, but it's a pain to deal with. This is my one slide where I get to complain about Scratch. I love Scratch. Don't get me wrong. It's a great, great program. They did wonderful work, but when it came to the extensions, they really did not do, in my opinion, very well. So what I'm thinking about for the future, I'm actually thinking of adding some things on. I'm not sure if it's going to be part of this program or not, because it complicates things, especially for younger students. But I just ordered a bunch of things. So I'm looking at doing some distance measuring. I ordered a sonar distance measuring device. There are 2 types. There's one that's very easy to interface to the microbit. It's a little more expensive. It's about $5 instead of $2. And I haven't had a chance to hook it up yet. And what that allows you to do is if you, it'll tell you how far the microbit is from some object. And it measures from 20 to 1,000 millimeters. I haven't gotten it yet. There's a motor controller to allow me to control both servos and DC motors. I'm thinking about building a little robot, and if I actually get that done, what I'd like to be able to do is use Scratch to control a robot using their radio network. So I'd have one microbit talking to Scratch, another one controlling the actual robot. And that would be a fairly low-cost solution to building a robot and having it remotely controlled. I'm looking at doing support for, they have additional pins between 0, 1, and 2. And I'm also now looking at Scratch 3.0, which is the next version of Scratch, which is totally in HTML5, which supposedly means it'll run on things like an iPad. I have, you can actually, it's a little bit of a pain to get working, but I have Scratch 3.0, the current state of it, working on my computer. There is some documentation for their next version of the extension specification. It looks very much like ScratchX, but it's not clear how they're going to handle that, if they're going to handle that the way they did with ScratchX. So let me just explain the difficulties with that. With ScratchX, you need to submit your extension to the Scratch folks. If they approve it, they then put it on their website. And that's fine. I mean, I understand that they want the control, but it's very difficult to do in terms of getting them to approve it. Again, there's really nobody in charge, and it's not clear who you write to. The other thing also is ScratchX is online. Now that they're, with the current version of 3.0, it's probably going to work like the Snap program. Snap is very similar to Scratch. Snap allows you to run online or offline with the same, essentially, you're just running a web application. You know, you just click on a link and it works. Hopefully that's what they're going to do here, and the extensions can run at least with the offline version. I know they're very protective of online because, you know, there can be some security risks. You know, people can write some things that are not really all that nice, that are nice. Okay, so that is basically the presentation. Any questions?
Sure. At the end, sorry, I didn't understand well. You compared the Scratch to Snap.
Yeah.
And you said that Snap, I don't know Snap, I've heard, but I never use it. It's not two different things for online and offline, is it?
Okay, so with Snap is written in HTML5. So Snap has a website, and you can program Snap online. But if you want to work offline, there's a little button on the web page. You download the HTML code to your computer, and then you can actually, by putting in the right URL into your browser, it'll actually execute it right off of your computer, and you don't have to go off, you know, online if it's easier. It's a pretty sophisticated program. The problem with Snap is it doesn't offer it only has one sprite that it comes with, which is an arrow. It's pretty boring. It does not have any backgrounds. You can put those in, but they're using it more as a teaching language at Berkeley, University of California at Berkeley. So it's more to teach programming than for the younger kids. Although I know Hummingbird, which is a robot that you can buy, they use it to control that for the kids. I don't know if they have any graphics. Eventually, they're supposed to have some graphics, but I'm not sure where that is. Building your own interface on Snap is very, very easy. The original name of Snap was Build Your Own Blocks, BYOB. And in some ways, it's a much easier interface to use than with Scratch in terms of these extensions. But it has its own issues in terms of it's not all that friendly for kids. It's not as much fun. The support is much better. There are two guys that are in charge, and you can get a hold of them. One is, I don't know if he's the head of the computer science department at Berkeley. The other one, he's resides in Germany. I'm not sure where he's working now, but you can get these guys on Twitter, and they answer questions. Yeah.
Jens, his name is Jens. He's German.
Yep. Again, you know, they make themselves, you know, they'll answer questions. They're pretty open. Not that the Scratch folks aren't, but they just don't. There's nobody. They haven't identified somebody as being a point of contact. There's no email. This is for extensions. There's no email address. There's nothing. If you send something out to Twitter, the only time I get responses is when I criticize them publicly, like when they broke things with the Linux version of the offline. My criticism was, I thought, very mild. I said that their support for Linux is fairly poor, and I got this defensive tweet back saying, no, we support it, but they don't. And even with ScratchX, to use those things on Linux, there's something you need to load into your browser. It doesn't work in Linux, and that's okay. I mean, it's their product, but they shouldn't pretend that they do. And again, they don't really have any support.
I just about this point, I met a guy who are, I think, in charge of this in Scratch team in France in the Scratch conference. His name is Greg. And
yeah. Greg is hard to get a hold of. I knew Greg before he went to work for Scratch, and he does a lot of the microbit that's on ScratchX. He wrote.
Really?
And
okay.
Why he did it only for the Mac, I'm not sure. I'm guessing because it's just easier, but it's a very limited audience. So they have a lot. You know, they have a small staff. They have limited budget. I understand all of that. But if there's a lot of interest in physical computing.
Little budget.
You know about the Scratch extensions. I asked him about the next generation of extensions, and it seems that they will it will be part of the official version of Scratch, and they will be made by Blockly style, not the actual extension style. They will change the way, and it seems that they want to make it more open. I mean, more not a separate site from Scratch. I think that they want to be like a part of Scratch for the next version.
That would be good. There is some documentation. So it is, if they stick to what they're currently saying, that extension is JavaScript.
Yes, Blockly style.
Yep. And it looks like essentially it looks like the coding is very similar to what ScratchX is now, and it's a much, not the site, but the actual interface. So the JavaScript interface looks like if you built a ScratchX interface, what they're doing for 3.0, at least right now, it can change, looks very similar. So you describe the blocks in JavaScript. You can actually process things. It makes things somewhat easier. So where one of the problems that we have with the HTTP side is, if you want to qualify a value a student is putting in. So let's say you wanted to make sure that the value the student put into the block was valid. You can't do that until that information comes from Scratch into the extension. So it adds more code in the extension itself, like in S2M, where in the JavaScript, since you can code, you can do that actually in the extension itself. On the Scratch side, you can validate the values before, and then if they put in an invalid, because it's JavaScript, you can put something on the screen, a little dialog box that says, you know, invalid, you know, try again or something. So I'm looking at that now. Hopefully we'll be able to, I don't know if they have anything that's working with the current version of 3.0. 3.0, they have a version of it now that's working, that you can actually, if you go to Google and look for Scratch 3.0 in their wiki, you have to hunt through it. There are some links. There's one that will actually, you can play with the latest version in your browser over the internet. And then again, if you hunt a little more on GitHub, they have the code and you can download that, and you got to play with it a little bit, but it'll work locally as well. So it does work, and it's looking pretty good. So I'm hopeful it'll be a lot friendlier. In terms of creating your own extension, the one thing, and I don't know how easy it is to do this, it's not easy, but it's certainly not designed for kids to create their own extensions unless they know JavaScript. And that I'm a little sad about. It would be nice if they created an interface where the kids could create their own blocks and do their own interfaces, but that's not the way it's going to be.
Yes, in Bordeaux we met Craig, and he's in charge of this whole. He's the programming director, as a matter of fact. And I met him again here in Brazil when we had the Scratch conference. So we can get in touch with him, and then we can talk about and send this specifically what you would like to tell them. So I think we can put you both in touch. It's very good to know that. Thank you, Alan.
If they're going to continue using the JavaScript interface, which is fine, and they don't, if they're not going to have this separate ScratchX kind of thing, where it's only going to be one site, and you're also able to run 3.0 locally, I don't really have a problem. If I find bugs, then fine. At this point, I don't think I'm going to need a lot of, or anybody else will need a lot of hand-holding. It's just that when there's a problem, you can't get these guys. So if I find anything, I'll let you know, and maybe we can get it to go together. The other problem is that they're not. They don't take advantage of the community, and I don't understand that. I know I had offered to help test a lot of this stuff. They didn't take advantage of that, and until they had a lot of complaints, there was a couple of bugs that were really nasty. They had claimed, the guy that was there at the time is no longer with Scratch. I mean, he's a nice guy, but he claimed that it was on my end, which is possible. I mean, I do have my own bugs, but I put together a scenario and proved to them that it was on their side. Spent a lot of time. They ignored it, and until a whole bunch of other people started complaining, they finally then came to me and asked if I would help isolate some of these things. And I'm more than happy to do it, but they just have a very strange attitude. And part of it, I think, is because they're under time and budget constraints, and some of it is their own ego. They won't accept that whatever they do isn't perfect, which is sad. But hopefully that changes.
Yes, I don't know. What I saw in the last Scratch conference in Boston, since then, 2016, we see that the community is getting bigger and bigger. And then at the end of the Scratch conference, they always make private sessions for people that are working like you do, that are contributing or asking. And what I saw is that the whole world is asking for a bunch of things, lots of things for working in many languages or many systems, a lot of things. Everybody's asking for something different. Maybe, I don't know, maybe it's that why they are a little bit closer. I could feel the same you were saying, because they started, it's more difficult to talk with them right now, I think, because the community is much bigger. So anyway, I think you are totally right, and your contribution is amazing. So we must to make the possible to put you together, or not, I don't know. So let's do what we can do that in this way. We can just.
The only suggestion I would have is, and it's not something that they would have to manage, but if they put together a way for the folks like me who are doing these extensions to be able to communicate with each other, so they don't have to hear complaints or suggestions from many, many people. If they just help facilitate having a group where we meet together and then have one person that puts together, comments or complaints or whatever, it would make it easier for them. I think it would improve their product, and it would help us as well, where we would be sharing. Right now, there is no community of Scratch extension developers. We're all kind of individual. I know Craig. I've spoken to him a few times, but we just don't do a lot of things together, which is.
Oh, you already know, Craig. Oh, okay. And for example, I know that they are working with Raspberry Pi, and they are connected to this big enterprise, and they are working together to make those extensions. So they are interested in making connections, but I don't know how it works. So, but I knew that in this last conference that they are doing a lot of connections with people and are working very much to do this extension stuff. So that's important. Let's talk about it.
Okay.
Thank you. So questions, Hajime, Anders, Sandy, Someone King, Veronica. Okay.
This is not a question. I want to tell everybody. Most of you are engineers. Well, I'm a teacher, and I think it's so important to students and the kids even when they know who is in the back of all this process and what is the work you need to do. And it's so important to know this is no magic, it's work. And maybe they can understand better what are they doing and what they need to do. And I love this session with you, Alan. Thank you very much.
Thank you. And by the way, one of my hopes, although nobody's doing this, all the code that I publish is available. It's written. I write mostly in Python, and I encourage people to change it if they want, to do whatever they want with it. I would hope that where they're teaching Python in the schools, that the kids might want to play with the code itself, just to see how things work. Hopefully the code is written well enough where they can understand it. I try to comment. In some cases, I do some I'll call it fancy things with Python, only because it's easier, and hopefully it's not too hard to understand. But yeah, it would be. This is where I would like the Scratch people to develop an interface where the kids can create their own blocks, and then write some simple either Python or JavaScript or whatever language they want to be able to write their own extension, just to see how all of the stuff goes together. One, it's not all that simple. They'll encounter all the problems, and they'll fail a couple of times, and then they'll get it to work. All the good things of education. But we're not there yet.
Yes, that's why this is a very special group. We have these people that has this open mind and this longer vision. So that's our group. Thank you. It's amazing. Someone King, would you like to talk something? You that met Alan's last week and last session, so we are discovering a lot of things. What are your impressions, questions? What else?
Hello, everyone. Thank you for Alan. It's an amazing presentation for us. In Korea, many companies developed devices for K-12 computing education. For example, sensor board, like a pick board, and Arduino. They call it Codino, like as Arduino in Korean versions. And microbit, indeed, Microsoft educator groups lead the microbit training course for teachers. So microbit is coming now in Korea. I think microbit is very powerful tool for K-12 students because it has some LED matrix. So it is very powerful tool for computing education, but it is not spread in Korea educator, but it's in this day it's coming now in Korea education, like with microbit, very powerful tool for computing education for K-12 students. There are some or a little material for microbit in Korea educators. So I want to develop the many material for with microbit for Korean educator. I want it. Yeah, thank you very much, Alan. Yeah.
Maybe you could translate those blocks for
Korean. Of course. Right.
So you have Japanese and Korean too.
Yes, I can translate the Korean document. Yeah.
One of the nice things about the microbit is that I think it's applicable from very young students because it's very easy to use to more advanced students and possibly even into college, because at the very lowest levels, which the microbit people exposed, they have what's known as a threading executive. It allows you to do multitasking. It's pretty sophisticated for such a little thing. There's a lot that you can teach with it, and it's applicable for for anywhere, I think, from kindergarten all the way through college. So it's a pretty exciting product. When I first saw it, I really didn't think very much of it. It looks kind of simple and not very interesting. But as I look into it, it has so much on it and so many levels that you can use it at. I think it's really going to be big. It just started getting big here in the United States. Another advantage of it, by the way, is, at least I'm seeing it here, the add-ons that you can buy for it, like there's a motor driver board. Because the microbit itself is so inexpensive, the motor driver board is also inexpensive. So the equivalent for the Raspberry Pi, they seem to be, at least here, pricing them about the same price as the board. So an equivalent motor driver board for the Raspberry Pi is about $30, $35, where the microbit board is $15, which is about what they get for the microbit board. So it's not only not only can you do a lot with it, it seems to be a lot more reasonably priced, which, as we know, in the classroom is very, very important.
Okay, Anders, would you like to talk something?
Yeah, I can say something. I have not so many questions, but it's a brilliant presentation. I just love it. And my little goal this weekend is to try this out with your program. So next week I come back with more questions, I think.
No problem. If you have any problems setting it up, it's not that bad, but there's a lot of little pieces you got to get going. Again, I have a manual online, and I'm hoping that, because I used to do things in PDF and publish the PDFs, it was annoying because people had to translate it. Now that I'm doing everything online, I'm hoping that the translators in the browsers are good enough, and the way I've written it, that it translates that other people can understand. And so hopefully the installation instructions are clear enough.
Yes, I'm just thinking about if you are using your program in school, it has to be very, very easy to set up. A lot of teachers are so stressed now, so it must like one button click and then it's going on. But I must try it out first. And then I'm very interested in your idea about radio contact with 2 microbits, and the other one is a standalone robot, so you can actually steer it from scratch. I think that's a good idea.
Yeah, I don't know how what the maximum distance is between the 2 microbits. I read somewhere where it was. I'm trying to think what it is in meters. I think they said 240 feet, which is divided, I guess, what is that, 70 meters or something like that. So it would work within a room. The other nice thing about it is that you can assign a channel number that the microbits talk to each other, which what that implies is that if you had several students with their own robots, they can each have their own channels for their own controller, and they wouldn't interfere with each other.
Yeah, I've tried that one. There were two kids making robots, and they was steering with those radio connections, and they had the same channel, so it was a little bit messed up. But we sorted out to give them one channel each, so that's okay. And I've tried this one. Some kids tried it, and I think it's about 30 meters or even more. If you are in a classroom, you can get out of the classroom and you have still radio contact with them.
Oh,
so
that's great.
Yeah, that's really great.
It's such a tiny little board. It's pretty sophisticated.
Yeah, I love it. Maybe the Bluetooth. I've seen people trying to do it with iPads in the classroom, and they're not really happy because there's some interference with Bluetooth and too many iPads, I think. But I don't know. I use the computer, so it's no problem for me.
So what I've heard is that there is an app that was given for free for Bluetooth for the for iPhones and Android phones, and I read somewhere online that they're now charging for it, and they were complaining. So, I mean, I think if you can put together even 2 microbits, there's a little. I think it's $10. There's a board that has a bunch of buttons on it. And essentially, it's a game controller for the microbit. SparkFun is selling it. So even using something like that, you know, I may try that if I can get everything else to work. Use that as a controller instead of Scratch, so that you don't have to have a computer in front of you. Once if Scratch 3.0 is successful, then yeah, you can use it. If you're able to use it with your phone or your iPad, that would be wonderful.
Yeah, we hope so. It's taking too long time because maybe I retire before 3.0 is out. I don't know. But I still love this one. I'm in a class right now, and we are making a project. So I just love it.
Yeah, 3.0, by the way, there's supposed to be either, I'm not sure if it's alpha or beta, one of those. You know, an early version is supposed to be out in the public, from what I read, the spring of 2018. So it's coming soon. I'm hoping that it does. And as I said, you can get, I'm guessing the version that's on that you can get off of GitHub now is pretty close to what they're going to come out with. and it looks pretty nice. It's based on Google Blocks, but it looks like Scratch. So it's not as clunky as Google Blocks is. It's the same block shapes that Scratch uses.
Mm.
Okay, anybody else has any question? We are about finishing. Hajime, do you want to talk something, to ask something to Alan's Adele?
Yes, I have a lot.
We are short
All
in
right,
time
because
right now.
I was writing all the points. So the first point, you were speaking about the community of developers and engaging kids with this project. They are making, I mean, these blogs. I got the same idea, and my goal is that kids they can produce something useful from the developers and from people for people around the world. So it's like you are doing this stuff, and the Scratch team, they are doing these interesting things, and these kids also they can do, and people around the world they can use what they work. So I think that it will make programming more fun and more engaging in the for the community if you see the other people around the world using your own blogs that you are making. So I think it should be a great idea. I wanted to do it, but I never did this before. For the microbit now in Tunisia, we don't have it. I never saw any kind of person using it, and I think the reason is that we are not selling it, and I don't know if it is worth to bring it from outside. For now, I never saw any kind of teacher just even experimenting. I never saw, even myself, I never used it before. But I think there is one missing point with the microbit. If they can add it, it will be amazing. If they can add an ESP8266, imagine they can do this. I mean, you can do really huge bunch of projects with IoT. You can really easily interconnect things together of your I mean, of your home, connect from with the internet, with your I mean, with HTTP requests, it's super easy. I mean, the communication with radio or Bluetooth. It seems that they have Bluetooth, but it's not that supported, or I don't know what is the problem with that. So I think if they add just the ESP8266 with it, it will be like a super product. What do you think, Alan, about the last point?
That's a good point. You could probably do that fairly easily by having an ESP board. There's actually a connector where those holes are for the ports. There are a bunch of other I/O ports, and there's a breakout board where you can plug that into a little wireless breadboard. I ordered one. I'm supposed to be getting it, I think, today, the breakout board. So you can probably, now it's obviously not user friendly, but you can probably wire it up where you can do that. I thought about the same thing. I have so many things I want to play with this. I don't know where to start first. But I don't own any of the ESP boards, but I'll probably order one and try that at some point.
Yes.
This is, the microbit seems to be, and this is an opinion, one of the better thought out, I mean, because it's the latest. Before that, the Raspberry Pi was my favorite board. I used to love Arduinos. I've gotten away from them because they haven't kept up. They work very well, but they don't offer a lot of new stuff. The Raspberry Pi is just amazing, but it's expensive. So I'm hoping the microbit guys are going to do this. I know that it's been very slow coming out to the rest of the world. One of their problems is that they haven't done a very good job of internationalization. So things like using, and I know in Python, I think it's the same, well, in the JavaScript block language, they show you the shapes. that you can put on the LED, like a heart shape or a square. So you don't need to know the text. But in Python, all of the text is in English. And so to get around that, what I did was I translate that. If you create a custom block for those shapes, I translate that back into the English for the board, but the blocks have the native language for that shape. So they haven't done a very good job in internationalization, but they're working on it. The other problem I heard someone, I can't remember who mentioned it last week, that the 5x5 matrix is too small for Asian characters. So for Chinese characters, I don't know about Korean, whether there's enough room for them, or Japanese, but the traditional Chinese characters, the Chinese have come up with a larger LED matrix so that they could support that. Eventually, I think they're going to get there. But it's to me, it's a pretty exciting board. It's too bad I didn't realize that it wasn't in the Middle East, and it could be distribution problems and tariffs and all this other nonsense that the governments impose.
I think one of the reasons is that there is no Chinese clone of that board. If there were a Chinese clone, I'm sure that it will be super cheap and everybody will use it.
There is a Chinese version that has the larger matrix. Again, I don't remember
the name. Sorry. Yes, I want to because usually the Chinese clones are very cheap and people they use them. Do you have the name?
I don't. I can't remember who mentioned it. Maybe one of the folks here did last week.
Yeah.
All right.
Yes, I think it was me. I think it's called Sinobit. SINO bit.
Okay.
If you Google it, you have the GitHub there, and I think more. I don't know where you can buy it though.
AliExpress, no?
Yeah, maybe. I think so.
Do you have the link or the name to put on the chat for us, others?
Yes, maybe I should see.
Yes. If you just Google Sinobit, you will have like interesting stuff. The name of the board.
Yeah, I could. Put it here.
I just put the link for the board itself up. It's in the chat section.
Yeah. Oh, sorry, 1 second later.
Thank you, guys.
we are competing. Who's the first Googler?
Okay. So we finish our time. For sure, we have a lot of questions and things to talk about. It's the end of this session, but not of our grouping and our interacting. So I'd like to thank you very much, Alan, for the amazing presentation, the amazing inspiration too for everyone. And you were not alone. Now we have a bunch of curiosity people to help you to spread the word. And let's push the people over there if they want to help or not. So let's do it, guys. Okay? Any final considerations, people?
I want only to express thank you very much, Alan. And I want to tell everybody this week we're going to send to Mitch Resnick the translations of Scratch in 7 native languages of Mexico, because we have a lot of languages here, but we have we're going to send him 7 translations, and they're going to be in the Scratch soon. and
languages options for these people, so these people can access to. That's amazing.
So their own languages. Yes, we have Otomi, Nahuatl, and another more. But thank you very much for all of you to have my day. You make my day.
Okay. Anybody else? So thank you very much.
Thank you so much, Alan. It was really interesting. Thank you for you, Louisa, also. It was really
Thanks
interesting.
for everybody listening.
Thank you so much.
Thank you very much.
Thank you.
Bye-bye.
Bye-bye.
So long.